data, that is the overview which we will see today. Okay, that is the general thing. Like, what do you mean by big data? What is the problem we have faced by big data, and what is the solution we have provided for that? Okay, that we are going to see. And in Hadoop architecture, we are going to see about like what and all the different core components are there, how they are going to work with each other, everything we will be seeing. And in module 2, we will be seeing about a bit about admin part, not in depth. As a developer, as I told, you should be able to install everything by your own. Okay, and a little bit about the configuration files which are needed for you. So that also I'll be showing you.
Okay.
And in data loading techniques, we'll be seeing about two different tools like Scoop and Flume, which are mainly used to transfer your data to and from your Hadoop. Okay, so we'll be seeing that practically as well. Right? And in module 3, we will be seeing about basic MapReduce, and in module 4, we'll be seeing about advanced MapReduce concept. So this we consider it as a development part. Okay, so wherein the basic core Java is needed. Okay. And in module 5, we'll be seeing about PIC. It is like English like scripting language, very easy to learn. And in 6, we'll be seeing about Hive. It is going to provide a data warehousing package. It is similar to your SQL. Okay, so this PIC and Hive is considered as the analysis part. Okay, and in module 9, we'll be seeing about HBase. It's a columnar database. Along with that, we also have one more service called as Zookeeper, which has been integrated with it. That also will be seen. And in module 9, actually till now whatever we have seen is the generation 1. Okay, so nowhere in the industry, as I told, they are not using this generation 2 yet, but maybe after 1 year or 2 years they might move to generation 2 as well. Okay, so for that purpose I just want you to have the up-to-date technologies knowledge. So I'm just including generation 2 features as well. Like, what is the extra feature that has been added to your generation 1? That we will be seeing here. And in module 10, we'll be seeing about Uzi, the workflow language. Okay, like you just want to specify the relationship over there. Suppose MapReduce job is there, PIC script needs to run, and Hive query needs to be executed like that. And one is dependent on another. Like after MapReduce finishes, it is going to give some output that should be fed as input to your PIC. Then after PIC finishes, it is going to give its output as input to the Hive query like that. One is dependent on another. So if you want to do it manually, you need to wait until MapReduce is going to finish, and after that start the PIC and wait until it is going to finish and then start Hive like this. Instead of waiting the time, we are just going to specify the relationship in Uzi. Okay, so it will take care of all these things automatically. And you can also do the scheduling, like periodic scheduling. At like every day at a particular time, say 10 a.m., this job should be run, or else depending on the data availability, this job should automatically start running. When you copy your input data set onto the cluster, okay, it should start running automatically like that. So you can configure that in Uzi. Okay, so we'll be seeing about that in the module 10. Along with that, I'll take up one real-time project scenario, and I'm just going to explain like where MapReduce is going to fit in, where PIC fits in, where Hive fits in, how to give the input, how to get the output, how all of them are going to work with each other. Okay, like that. It is not compulsory that you need to use all the technologies in a single project. It depends on the data set, your requirement. Okay. So you're going to use the technologies. So we'll be discussing about that, when to use which technology like that. So here we will be seeing about all the theory. Yeah.
See, I'm from the data analysis and completely from the data analytics background. Well, I'm currently working on Excel, SQL, and Tableau.
Hmm.
So I have absolutely no a clue about Java. So is Java mandatory to learn Hadoop, or will it be okay without Java? How is it? Because I don't know the Hadoop industry, because I know this analytics industry. I
Hmm.
still don't know the Hadoop industry, or of what kind of jobs would be there and what kind of tools.
Yeah. Okay. So actually, for MapReduce, basic core Java knowledge is needed. Okay. But if you want, what I can do, not in depth obviously, because Java itself is a separate course in fact, but whatever is needed for the MapReduce point of view, okay, that I can cover it in 2 to 3 classes.
Okay.
Okay. So we'll not
And
be
for
going
other
in
things,
depth all those
and for
things
other
here.
things like Pig and Hive, is Java required for that?
Not necessarily, in fact, it is not needed. But if you want to integrate, you can also integrate Java with it. That's it. But it is not compulsory.
Okay.
So the usually what happens, the people who are very good at Java, they usually go on development side.
Uh-huh.
Okay. And the people who are good at SQL, they usually go on Pig and Hive, that is analysis side,
Okay.
like that. So no need to worry. In fact, you'll be having different teams. In fact, so what depending on the data set, you're going to use the technologies as I told. Okay, it is not compulsory that always you need to use the MapReduce. Sometimes you may directly use Pig and Hive itself, or else if it is needed, first the data set is given to the development team who are responsible for refining the contents, just converting from one format to another format so that it can be given to the analysis team. So they are going to handle it like that. So it depends. Okay, I'll tell you where how it is going to be used and all.
Okay.
So any other clarification is needed regarding contents?
No.
Okay, so we'll just move forward. Okay, so by the name, okay, uh, I just want to ask you, what do you people think about big data is in generally?
Uh, in general, it is an enormous data.
Okay, correct. Anything else? Prasanna, do you want to say anything?
No, same thing. Lots of data basically. Huge data.
Okay, I think Prasanna, you're far from the mic. Can you just come closer to your mic?
Yeah, I mean huge data is it.
Yes. Okay. Good. Both of you have given the same answer. Whatever you have given, that is correct. But along with that, we have something more, in fact. So according to Big, you are saying like it's a huge amount of data. But we are not only talking about volume here, we are also talking about complexity here. Complex data. So what do you mean by this complex data? Complex is nothing but unstructured data. So we have the combination of structured, unstructured, semi-structured, quasi-structured and all. Different types of data are there. So mainly first we will discuss like structured and unstructured. Okay. Then we will move to the further different data types. Okay. So what exactly structured data type means? See, if your data is having a particular format in the form of rows and columns, so that is called as a structured data. Suppose if the data is not having a particular format, okay, so we cannot predict how the pattern is going to follow. Like take the example of this PDF file itself. Okay, so in this particular slide, I have uh, all the data which has been almost filled up. Okay, in the entire slide along with the image here. In the next slide, I might be having different information. Right. Suppose I might be having only 2 lines. Okay, I might not be having images like that. Different type of data is there, right? So we don't have the same pattern here. So this is called as unstructured data, which doesn't have any particular format. So if you take your traditional databases like MySQL, Oracle, anything it can be, so there you're going to store your data, right, in the form of rows and columns, which are going to have a predefined sizes. Okay, and it is going to follow the same pattern. How much size is going to be reserved for each field is going to be predefined. Okay, so they are considered as structured data, and your images, audio, video, or log files, your PDF, text files, all these are considered as unstructured data. Okay, so now here we are talking about big data is nothing but huge amount of data and also complex data. That is nothing but it is a combination of structured and unstructured data. So which we need to store in some container, okay, and process it, and wherever you need you can retrieve the result as well. That should be done. But the thing is your traditional approaches which are not supporting this complex data. Okay, using our traditional approaches like MySQL, Oracle, any RDBMS concept, using that we cannot store the unstructured data here, and it also has some limitation in the size wise. Okay, so it cannot store huge amount of data. That was our problem. Okay, big data is nothing but we have huge and complex data that needs to be processed in a well manner. But using our traditional system, we were not able to do all these things. Okay, for that we needed a new solution which can handle this problem. Okay, so before seeing about the solution, first we will see what are the different types of data that is going to be generated. Okay, which we can call it as complex data. Let me take the example of aircraft. So an aircraft, it is going to generate, okay, 10 terabytes of data for every 30 minutes of its flying time. I'm telling like for every 30 minutes of, I'm taking the example of aircraft here, right? So I'm just telling like for every 30 minutes of its flying time, it is going to generate 10 terabytes of data. So you can imagine if the journey is around 6 to 9 hours, then how much data it is going to generate. And the data what we are talking, okay, is going to be stored in the block box. Have you people heard about block box? What type of data is going to be stored over there?
It's basically the kind of voice recording done at the cockpit.
Okay. So it is going to contain all the details about your aircraft, including the conversation between the station and the pilot people.
Yes, yes, very much, and even the technical specifications of the plane.
Yes, exactly. So why do we need to store this data actually?
In case of any incident, that will be very helpful.
Exactly. Suppose if an aircraft met with some accident, we want to find out the cause. We cannot ask anyone, right? No one is alive over there. So what we are going to do is we are going to retrieve the data from the block box. Okay. So in the block box, we are going to have log files, in fact. The data is going to be stored in the form of log files. So these log files needs to be retrieved and it needs to be analyzed so that they can find out the cause. Then only they can take some precaution. If any technical issues were there, okay, it should not be repeated in any further aircrafts. Okay, that can be taken care like that. Okay, so here what are we also unstructured data. Log files are unstructured data. Okay, so if I'm going to take one more example, say Facebook. Okay, Facebook is a social medium, right? So what type of activities usually people are going to do on the Facebook? They are going to upload the images, audio, video, right? The status messages they are going to update, and they are going to chat with their friends, the text messages, right? So all these are which type of data actually?
Unstructured data.
Exactly. Okay. So here we are dealing with again unstructured data. And also we are dealing with huge amount of data because Facebook, it generates 1 petabyte of data for every day. See, if you take in 1990, were the people using Facebook?
No.
But now if you take, even if you consider the school child also, he is going to have an account in the Facebook, in fact. Why
Yeah.
so much of difference? Because of the advancement in the technology, I can say.
Yeah,
Is it so?
advancement as well as the mode of interaction.
Exactly. And I can say it like the internet speed has been increased a lot and the price has been decreased a lot. Earlier, okay, we used to go to the browsing center. Even if we want to download a 10 MB of data, we need to sit for a longer hour. It's minimum 1 hour, and we need to pay the money over there. We are going to have the slow internet speed, right? That was the
Hello.
problem which was there earlier. But now what happens actually? In every home, almost everyone are having the internet facility, right? So why?
Right.
As I told, the internet speed has been increased and the price has been decreased. So even if you don't have any work to do, still you will be browsing one or the other thing, right?
That's correct.
So this is all happening because of the advancement in the technologies. So that only the unstructured data generation has been increased a lot. Okay. So that's what I just meant to say. If I'm going to take this second example, that is Facebook, there also we are dealing with so much of unstructured data and also huge amount of data. Okay. So if I'm going to take one more example, that is NYSE, New York Stock Exchange. So here, okay, so if you have done this one, so you would like to take the opinion of one analyst person before buying or selling anything. Do you agree?
Yeah.
So how he is able to provide the suggestion for you?
Probably looking at the previous trend of the trade, the stock.
Exactly. So where is this stored actually? Which type of data we are going to have here?
I think
We are
he
going to have
used
the,
numerical data.
yes. Okay. This is also the unstructured data, okay, which we are dealing here. So actually the analyst person, he is going to take some 5 to 10 years back data, okay, and he is going to find out one pattern saying like for every 6 months the price of this particular stock is going to increase, or for every 2 months it is going to decrease, okay, like that. He's just going to find out one pattern. Depending on that, he is going to give the suggestion for us. Okay. So the data
The,
which we are dealing here,
the,
yeah,
the data which analyst gets, especially the stock price, even if it is 10 years, why it is unstructured? It should be structured, right?
I'll tell you what is the problem. I'll tell you.
Okay.
So this is in fact unstructured data. This is not a structured data. The trading data, what we are going to deal with, we are not going to have a same pattern. It is going to vary, right? So we cannot say like if it has yesterday if it has been increased, today it is going to increase something more. It might decrease, or else tomorrow it might increase. So we cannot predict the pattern, in fact. Okay, so we call this as unstructured data, which doesn't have any particular format, in fact. Okay, so here also we are dealing with unstructured data as well as huge amount of data, because NYSE generates around 1 terabyte of data for every day. Okay, so earlier what was the thing is, whatever the solution we had, okay, the solutions were not able to process both the things, like regarding volume also, regarding complexity also. Okay, so we need a solution which should handle this huge amount of data as well as complex data, because we are seeing so many scenarios wherein we are going to face both the problems, right? So these are the some real-time examples which I gave. So wherein we are going to face the same problem. Okay. Prasanna, do you want to ask anything? Is your doubt clear?
No, basically you mean I still, if you say the trade analyst considers other factors like the market conditions depending on the news and other things, that I
Yes,
can
yes.
understand as unstructured data. But if it is, if you are saying only the stock prices and the time and volume and other things, I think those are structured data.
Fine. You will understand once I'm going to tell you about the dimensions, different
Okay.
dimensions of big data. I'll tell you in the further slide. Okay. So that time I hope your doubt will be cleared.
Okay.
Okay. So here you can see the data volume in 2011, it was around 1.8 zettabytes. By 2020, they are predicting like we are going to get around 40 zettabytes of data. So you can see here 1 kilobyte means these many bytes. So we are talking about zettabytes here, which is very huge, right? So you can observe the data is getting doubled for every year. Why is this? As I told, because of the advancement in the technologies. So you can see nowadays all the people are also going for WhatsApp. Everyone will be having WhatsApp in their mobile nowadays. So they are also generating data, right? Data is getting generating from different sources. It may be from web server, app server, sensors, or else, as I told, it may be by the new social medias, okay, your mobiles and internet in the mobile because of that. So all those things are generating huge amount of data. And I can say for every year, the data generation has been increased a lot. In fact, it is doubling. Okay. So these are the different types of data which are there. Unstructured and structured, as I explained. Structured is nothing but which is going to have a particular format in the form of rows and columns. Okay. So the data which is stored in your traditional databases are all considered as structured data. Okay. And semi-structured is nothing but half of the data is going to be structured and rest half of the data is going to be unstructured. Like your XML files, which are going to have multiple tags. Okay. And quasi-structured is nothing but in the Facebook, okay, if you observe at the right side, okay, you're going to get some ads. Okay. If you like that product, you're going to click on the like button over there. Alright. So the data which is going to be generated is considered as web clickstream data, and it has been categorized as quasi-structured data. Why do we need to store that data again? Because we want to find out the market, right? How is the market for this particular product? How many people are liking this product? If the people are not liking this product, okay, then what is the next step we need to do? Like if any improvement is needed, or else if many people are liking this product, I can open a new shop for this product, right? Like that. So depending on this data only, they are going to make the strategic decisions. Okay. And unstructured, as I told, all your text documents, PDFs, images, audio, video, which doesn't have any particular format, okay, is going to be considered as unstructured data. Okay. So if you see this graph, okay, from 1970, the data generation has been started and it has been increased, okay, linearly. I'm talking about structured data here. Okay, the structured data has been increased linearly. But if I'm going to consider the unstructured data generation, it has been increased exponentially. Okay, it has increased a lot. Just consider this overall data generation. 80% of data is unstructured data only. Only 20% is structured data. Okay. Earlier, what used to happen is we used to have structured data more, and we used to process that one. We just used to neglect the, if we process only structured data, that is enough for us. We get the profit from it. But now, since 80% of data is unstructured only, so it is a peak time for us to find out a solution which can deal with this unstructured data, so that we'll get more business profit. Okay, this is the current situation. So these are the different dimensions of the big data. Okay, so here we have 4 V's. Okay, we need to find out a solution which can handle all these dimensions effectively. Okay, volume is nothing but we are getting a huge amount of data nowadays. It can even start from petabytes, it can even cross zettabytes of data. Okay, our solution should handle this huge amount of data. And data is getting generated in a very fast manner. Like if you take the example of Twitter itself, for every 5 seconds, okay, 5,000 tweets are going to be generated. Means in a very fast manner, data is being generating. So your solution should also handle this fast movement. Okay, and we are getting different types of data, structured, unstructured, okay, semi-structured, all different varieties of data we are getting. Okay, you should also handle that one. Coming to the veracity. Okay, so as Prasanna has doubt, okay, the trade data what we took, it was the combination of both structured and unstructured data. Okay, we need to consider all the combination there. Okay, but what is the problem here? I'll tell you. When you consider this one, okay, this data is not going to be constant. It is volatile. Okay, the data keeps on changing. It is not the constant data. And also, okay, the data which we consider here, okay, might be having the null values. Example, if you take some form, okay, in the form you need to enter your first name, last name and all, okay, mid name and all. So some people, what they do, they just go for entering only first name. They'll skip off the last name, mid name and all. Okay, means those blank values are going to be filled with the null value. Null is nothing but unknown value. Okay, so if you are having such unknown values also, okay, still your solution should handle this data in a well manner. Even if there is an uncertainty in the data which keeps on changing, which is a volatile data, and even if it is having a null data, still the solution what you find out should handle such type of data. Okay, and also it is nothing but like if you take the example of search engines, you have so many web search engines, right? Which one you prefer to use?
Google.
Usually?
Google.
Yes, correct. Why so? Because whatever you're going to enter in the search box, okay, related to that, you're going to get the exact links below. Means you're getting the accurate data. Okay. So here also, veracity is talking about you should deal with all such type of data. Apart from this, you should also give the accurate result. Okay. So whatever the solution you're going to find out, your solution should handle all these type of V's: volume, velocity, variety, and veracity. Okay. So before seeing about the solution, first we will understand what do you mean by DFS. DFS is nothing but distributed file system. Okay. So first take this example, like I want to read 1 TB of data using a single machine, which is working with 100 MB per second speed. Okay. How much time it may take to read 1 terabyte of data with this particular speed? It is going to take around 45 minutes. Okay. But if I'm going to distribute this data, okay, I'm just distributing the data among 10 machines. Like if I have a single book, okay, if I want to read that book, I'm going to take 3 hours time. Okay, so what I'll do, I'm just going to divide that book into 3 different parts. Okay, so part 1 is given to person 1, part 2 is given to person 2, part 3 is given to person 3. All have started working, okay, simultaneously. Okay, so as a unit, so how much time they are going to take to read that entire book as a unit? It is 1 hour, right? If a single person is going to read the entire book, he'll take 3 hours. I'm dividing the book into 3 different parts and giving it to 3 different person. All have started reading the book, okay, parallelly. They are performing their task. So orally, how much time they are going to require to complete the entire book as a unit? Obviously 1 hour, right? Within 1 hour, first person is going to complete his task, second person is going to complete his task, and third is going to complete his task. Okay, like that. So in the same manner, we are just going to distribute this data, divide this entire data into multiple blocks, and we are going to store those data onto different machines. See, we are not increasing the speed here. In fact, each machine is working with the same speed, 100 MB per second. But all these machines are doing their task parallelly. Okay. So, if you're going to distribute the same 1 TB of data among 10 machines which are working with the same speed, then you're going to take around 4.5 minutes to complete the reading of this data. 45 minutes. If you're distributing the data, it will take around 4.5 minutes. Means we are saving a lot of time here, right? Nowadays, see, storage is not a problem for us because the hard disk price has been reduced a lot. Okay, so we can purchase any of the machines, any of the hard disk, and you can store your data. The problem is reading that data. Okay, we have huge amount of data. Okay, but we have less. We just want to spend less time to read the data. Right. So if you agree, okay, so earlier our ancestors, they used to give more importance to money than time, right? We'll be getting some messages like they used to walk for 20 miles to save 20 rupees. But now we spend 20 rupees to save 20 minutes of time because we give importance to time now. right? In the same manner, in a less time, we want to read huge amount of data. That is not possible by using a single machine. So it is possible by using a distributed file system, DFS concept. Okay. But the problem is if you are distributing your data among multiple machines, okay, the home directory information is stored here, reports information is stored here, okay, like that. So if you want to retrieve that data, you need to remember the IP address of that machine so that you can access the data. If you are having 4 to 5 machines, you can remember. But if you are having 400 to 500 machines, practically it is not possible to remember the IP addresses, right? So for that purpose, we use a concept called as consolidation. So we are just going to use a gateway server, okay, which is going to act like a entrance to your central mall. If you just go to the central mall entrance, that is enough. You'll find all the categories. You'll also find the cloths, utensils, electronic goods, everything. Okay. So in the same manner, you just need to remember only this URL. Whatever the request you want to send it to here. So this is responsible for diverting your request to a particular machine and fetching the results for you. Okay, like that. So DFS is mainly used to reduce the time taken to read the huge amount of data. Okay. So first we will understand what is the limitation which we have faced by our existing industry. Okay, then we will see about the solution. So you can see this diagram. This is the instrumentation layer, that is nothing but data generation phase. Data may be getting generated by anything like app server, web server, or sensors, as I told, or social medias, anything it can be. Okay, and this data has been collected here. Okay, and after that, this data is going to be stored onto the grid. Here grid is nothing but collection of multiple computers. Okay, so which are of high-end servers here. Okay, then you're going to use the ETL tool to extract whatever the required information is there from here and transfer it to RDBMS. Okay, where you're going to do the processing. Okay, and after that you're going to use the BI tools here, like as Prashant said. Okay, tab view or MicroStrategy or click view, anything it can be, using which we are going to generate the reports and dashboards. Okay, this is the usual procedure which is going to be done in the industry level. But what is the problem we are facing, that we will see. See, whatever the data which we are getting here, that we are storing here, means we are going to store both structured and unstructured data. Okay, but the thing is, okay, we are doing the processing at RDBMS layer. So RDBMS is nothing but which are going to consider your traditional system like MySQL, Oracle, or Teradata, anything it can be. Okay, so which stores only structured data. It doesn't store unstructured data. It means we cannot do processing of unstructured data. That is our one problem. Okay, see, processing is done at this layer, but we have both structured and unstructured data here. And your RDBMS, it supports only structured data. It means it processes only structured data here. We are not able to process the unstructured data. That is our one problem. And another problem is we have huge amount of data that needs to be transferred, that needs to be retrieved, okay, in a faster manner. But using ETL, okay, we cannot retrieve huge amount of data in less time. It doesn't scale. Okay, so that is our second problem. And the third problem is premature data death. Means, if you take the example of Yahoo, Yahoo uses 4,000 node cluster. Okay, so after some time, okay, when the data is keep on generating, you have stored your data onto the cluster, it has been filled up. Okay, now some new data comes in. You don't have any space on the cluster. So what you are going to do? They are going to take the backup for every 1 year. Okay, whatever the data that is there, all the backup is going to be taken. Maybe in any other storage media or anything it can be. Okay, tape or anything it can be. So that you'll get the space in your grid. Okay, you're taking the backup from here and storing it some storage like any storage media, so that all the data has been deleted here. You'll get the new space to store the new data. Okay, that is the thing what they are going to do. But the problem is, okay, so to perform the analysis, they need the historical data. Like in NYSE, as I told, they are going to take the 5 to 10 years back data. Okay, so if you want to retrieve that 5 to 10 years back data from the grid, but it is not present here, it is present in some storage media. So you need to access this one. For accessing the storage media, okay, what you need to do is you need to issue so many requests, like ask the permission from your higher authority, and lots of paperwork are going to be done. So by the time you access this data, it is going to be like around 4 to 6 weeks has been wasted only for accessing this data, not even for analyzing. Means we are wasting so much of time here, right? So this is our third problem. Okay, when we want to do the analysis of the historical data, data is not present on the grid. We need to waste so much of time to access the data. Okay, that is our third problem. So now we will see about the solution. Okay, how it has been solved, all these three problems. So same thing, instrumentation is nothing but data generation phase, and it has been collected here, and it is going to be stored onto the Hadoop. It's a grid. Okay, Hadoop is the solution to handle your all big data problems. Okay, Hadoop is a framework, we say. So it is going to provide two things. One is storage as well as computation. Okay, so whatever the data, okay, you are giving here, that is going to be stored onto this Hadoop grid. This is also nothing but collection of multiple computers which has been connected together. And we are using low-end machines here. We are not investing more money. Okay, so we are storing the data here, as well as we also have the option for processing. We can also process our data here itself. So our first problem is solved. That is, we can able to process our unstructured data. Okay, so the first problem is solved. And the second problem is we are using a concept called as HDFS, Hadoop Distributed File System. So I have already explained you, using the DFS concept, we can save a lot of time, okay, to retrieve the huge amount of data. So our second problem is also solved. We can retrieve huge amount of data in less time using Hadoop. Okay, so coming to the third problem. See, yes, it is a grid, obviously. So we have a collection of computers. So suppose if the space in this grid has been filled up and some new data comes in now, okay, you don't have space to store here. So what you're going to do is you're simply going to take one more machine and just add it to the cluster without altering any current configuration of your cluster. Okay, we are not changing any configuration of the cluster. It is working as it is. We are simply adding one more node to the cluster, so that we'll get some new space and we can store our new data there. So like that, you can add any number of nodes. There is no limitation. Okay, so it is scalable. Okay, and whenever you want to retrieve the historical data, it is present in the grid itself. You're not going to waste much time. Okay, like that, our third problem is also has been solved. So Hadoop is the solution for handling the problems which have been faced by your existing industry. Okay. So now we will see what is the difference between your MapReduce, okay, that is Hadoop, and your traditional system. So if you talk about data size, your traditional system can hold up to gigabytes of data, maximum 1 terabyte. Sometimes you are also going to face some performance issues. Okay, but Hadoop, it can even start from petabytes, it can even cross zettabytes of data. There is no limitation. And accessibility wise, just give me a second, I'll be back. Yeah, I'm back. So coming to your second point, that is accessibility wise. So in traditional system, it is interactive. Your Hadoop is mainly designed for batch processing. It doesn't mean that you cannot run a single job. You can also run it. But the power of Hadoop you'll come to know when you're going to deal with huge amount of data. Okay. And updates, you can read and write many times in the traditional system. Like if you take the example of ATM, each time when you withdraw the amount, okay, it should be updated in your database, even if you have withdrawn 5 times in a day. Okay, means read and write many times. But in Hadoop, we are going to copy our data set once onto the Hadoop, and then we are going to analyze it many times. Okay. And structure wise, it is static schema. Before storing anything, you need to define the schema. Okay. And here it is dynamic schema. You can do it on the fly. Integrity wise, it is high because we have all the things at one place. But here we are going to distribute our data among multiple machines. And what is the advantage of distributing the data? We have also seen, right? We can achieve the parallel processing and we can save our time. Okay. And scalability wise, it is non-linear. Okay. Means you cannot increase the size, but here it is linear. Okay. As and when you need, you can simply add up the nodes over there. Right. So now we will see what exactly Hadoop means. Okay. I'm just dividing this 2 lines into 5 different sentences. Okay. That is, Hadoop is a framework. Okay. No need for us to build everything from the scratch. Okay. The basic stuff is already present. We can just reuse it. And it allows for distributed processing. Distributed is nothing but we have already seen HDFS concept. Okay. Of large data set. As I told, Hadoop is mainly used for dealing with huge amount of data across clusters of commodity computers. Commodity is nothing but low-end machines like our laptops and desktops. We are not investing more money here. Okay. Using a simple programming model that is nothing but MapReduce. Using the MapReduce program, we are just going to analyze the data. Okay. So Hadoop is nothing but it is a framework to deal with your big data problem. Okay. It allows for the distributed processing of huge amount of data across clusters of low-end machines using a simple programming model. Okay. This is what exactly Hadoop means. And it is open source, so freely available. Okay. No need to pay anything. And this is the history about your Hadoop. Okay. It was created by duck cutting, And in 2004, Google published a paper, that is Google File System. In that they had mentioned about this. And the nudge, that is the web search engine, it uses MapReduce in 2005. And in 2008, it becomes the top level project, okay, of Apache. And in 2009, Yahoo used this Hadoop to sort 1 TB of data only in 62 seconds. So you can imagine, okay, how fastly Hadoop is dealing with huge amount of data. So by this, it has got more popularity, and nowadays everyone are migrating to Hadoop. Okay, what makes this Hadoop more useful? Scalability point of view, that is nothing but, as I told, if there is no space in the cluster, if you want to store some new data, you can simply add some more nodes to the cluster, okay, without altering the current configuration. So you are going to get some new space to store the new coming data. And economical, because we are using low-end machines, we are not investing more money. And it is efficient because we are doing the parallel processing. Okay. And reliability wise, see, whatever the data that comes to your Hadoop, that is going to be divided into multiple blocks, okay, and each block is going to be replicated 3 times, okay, and it is going to be stored in different machines. Even if one machine goes down, still you can get your same data in another machine. You will not be losing your data, okay. So we call Hadoop is reliable. Okay. Who and all are using Hadoop? These are some companies. Okay, we have something more in fact. Okay. And these are some more use cases. I have already explained some use cases like aircraft example, Facebook, NYSE, like that. Okay. Similarly, we also have some more examples in which and all scenarios the data, huge and complex data, is going to be generated. Okay. And these are the different types wise, okay, images, movies, audio files or video files, okay. And in medicine, MRI, CT scan, X-rays, okay, like that. So in science, humanity, and in business, different type of data has been generating. Okay. What are the current challenges which are there? See, we have huge amount of data that needs to be analyzed, but we have less resources. Okay. Always vertical scalability is not the solution.